Hi folks, good morning. We're going to get started now. Once again, this is the Troubleshooting Network Performance Issues with Active Measurement, not the NetOps coding one. That is going on over in the Grand Ballroom. So it looks like everyone is here who wants to be here. Welcome, thanks for coming. And without further ado, I'm going to introduce Brian Tierney of ESnet. Brian has been instrumentally involved in the Persona project and a bunch of other active measurement projects for the last several years. And he is an excellent source to be learning about active measurement from. So I'm very excited about this tutorial. Brian.
Okay, good morning, everybody. So I'm Brian Tierney from ESnet. These slides have just been uploaded to the NANOG website. Apparently there's actually two sets of slides. The most recent ones, which aren't that different than the other ones, are the second set. And some of the slides have pretty small font, so you might want to download them so you can look at them on your screen instead of up here, just as a heads up on that. And I like it when people interrupt me and ask me questions as I go, although let's save like philosophical discussions till the end. I think the room is small enough you can just yell out the question and I'll repeat it. You don't have to get up to the microphone, but we'll see how it goes. So just briefly, so you know where I'm coming from, because all speakers bring their own sets of biases, right? I just give you a really quick overview of who I am and what my background is. So I've worked at Lawrence Berkeley Lab across the bay. I don't know, can you see it from the 32nd floor? I haven't looked. You might be able to see it, I think, from, yeah. Berkeley Lab is one of several Department of Energy labs that do a lot of big science. We have big supercomputer centers, we have big accelerators, we have something called the Advanced Light Source. All these things generate huge data sets that various researchers around the world want to download and look at. So we've been trying to help researchers download very big data long before the term big data got popular. About 10 years ago now, I started working for ESnet, which is located at Berkeley Lab. This is just a picture of our network, which recently extended to Europe. And again, that's blurry enough that I can't read it, but maybe you can read it in the back of the room. But we connect all the Department of Energy labs. We also connect to CERN in Europe, and many of the labs now have 100 gig connections. So our traffic profile looks quite different from the commercial internet in general. It's a relatively small number of very large flows. Again, we have mostly 100 gig sites. We have lots of what we call data transfer nodes, or DTNs, that are 10 gig or even N by 10 gig. There's a few 40 gigs out there. These hosts typically run parallel transfer tools such as grid FTP. And have very high requirements. So this is the world I'm coming from, trying to make networks work for these really huge data sets. So that's just some background. So I'm going to give a brief introduction to the Persona Toolkit next. So Persona was originally developed to help troubleshoot large science data transfers, because that's where we're coming from. For example, the LHC data at CERN, large genomic data sets, genome data sets are actually quite huge, et cetera. But we really do believe these techniques are useful for any network, any environment doing large data transfers. We have more and more scientists transferring data into the Amazon EC2 cloud, for example. We're constantly hearing about Hollywood doing really huge data sets, moving things around. And there's more and more big data applications that have been in the news lately. So whereas 10 years ago, I think this maybe was a problem more in the science space than in the commercial space, I think these days it's probably a problem for all of us. So Persona was designed for the following. It's a tool to set network performance expectations. In our world, we like to let our end users know what to expect. And we find that in general, users' expectations are really low. They're used to home networks and things coming in at a trickle. And if you have end-to-end 10 gig or 40 gig or 100 gig paths, what should users actually expect? And we're trying to teach people that they should expect 10 gig or 40 gig. Persona is really good at finding network problems that we refer to as soft failures. I'll go into some detail on what that is and to help fix these problems. Now, another key point about PerSonar was always designed from day one to work in a multi-domain environment. There's a lot of commercial tools out there that work in a single administrative domain, but PerSonar was always designed to work across administrative domains. And of course, these types of troubleshooting problems are much, much harder if there's multiple administrative domains involved. I think everybody's probably aware of that. And PerSonar also provides some standard ways to actually publish the data. There's a REST API with the standard schema so that various people can download the data, the raw data, and do analysis on it. So in practice, we find that performance issues are pretty common. And when the network is underperforming, it can be quite difficult to actually understand the source of the problem. I mean, step one is just to be able to notice that the network is underperforming. But then step two, pinpointing is still fairly difficult. And the other thing that we found over and over and over again is that local testing is just not sufficient. A lot of problems only show up when you're going fairly far away. So here's a common use case that we find. And again, these slides have a lot of sort of R&E network terminology, but I think you can replace campus with corporate office and NREN with commercial network. But the general idea is you're transferring it a long distance between campuses, and that it's going to go across several different networks potentially. And each of these networks may have great monitoring and great testing within the network. But there's a whole class of problems, multiple classes of problems that only show up when you go between them. And problems might be between two networks. Problems might be something dropping a small amount of packets, as we heard from Facebook yesterday is a good example of this, that the problems aren't really going to be that noticeable if you're going fairly close by. But when you're going further away and kind of the magic RTT value is 10 milliseconds, and you'll see from a TCP curve coming up that less than 10 millisecond RTT, a little bit of loss you can tolerate, you might not notice, but more than 10 millisecond RTT, there's a huge performance impact. So these are the kind of environments that PerSonar is targeting. So for those of you who saw the talk from Facebook yesterday, it talked about how much packet loss can TCP tolerate. This is pretty much the exact same graph presented in a different way. And this is actually a real case from ESnet a few years ago, that we had a failing line card that was dropping 0.0046% of the packets. Sounds like nothing, right? And also, this was not being detected in the hardware counters. The failing hardware component was beyond the last counter. So it wasn't showing up anywhere. And so we ran a series of tests while we had access to this broken network. So the top line is the good direction. It was only dropping packets in one direction. So this is round trip time on the bottom. And then the other lines are, we tested it with TCP Hamilton, TCP Reno, and sorry, that's the blue line. Theoretical, there's something called the Mathis equation. It's been around since 1996. This is, not new, that predicts this TCP's behavior. And the theoretical is for Reno. You'll see that it fits that curve quite closely. And sure, Hamilton is 2 or 3 times better than Reno / theoretical Reno, but 2 or 3 times crap is still crap, right? So you see that, if you're operating in this domain, you're not going to notice anything. But anything beyond about 10 milliseconds and performance is just really, really terrible. So we really have to try to architect the networks for near zero loss and to be able to understand the source of that loss. And the other thing to remember is hardware counters lie. There's a class of problems that you just have to do active measurements, otherwise you're not going to see them. So we call this type of problem a soft network failure. Soft failures are when basic connectivity functions just fine, but performance is reduced. You know, your pings will get through just fine. The network's not down, but there's something wrong with it. And, you know, of course, TCP was designed to hide these sorts of issues, so it makes it harder to figure out what's the source of it. As I mentioned, many soft failures in the TCP world really only affect long RTT flows, because TCP recovers much faster at short RTTs. And we've seen case after case after case of these soft failures that have been around for years. Somebody will make a configuration mistake 2 years ago, and they'll finally dig into, gee, I wonder why things are running so slow. So these things can be rather subtle. And you know, hard failures are the things that standard network monitoring systems are good at. A lot of commercial tools are out there, a lot of open source tools that are good at detecting hard failures. You know, things like a fiber cut, a power outage, a hardware just completely failing. We're good at detecting that stuff. We're good at fixing that stuff. We're good at routing packets around that stuff. The thing we're not so good at is soft failures. So, yeah, just for fun, I have a slide that shows a type of hard failure. I just love this image, so I'm throwing it in sort of gratuitously. It's a shark attacking an undersea fiber cable. I don't believe it got through. It looks like the cable's still intact. But again, we're good at detecting that sort of issue, although this one's a little hard to fix. But that's a fun image that I just wanted to throw in. Now we have to try to distinguish between soft failures and network congestion. Of course, congestion will also cause loss, and congestion is pretty easy to detect and understand. You can confirm it using your SNMP counters, and you can fix it by spending money. So that, you know, this is not a soft failure. This is not what we're talking about, although it's important to understand which of your links are in fact congested, of course. There's other things that drop packets that are harder. Underbuffered switches is one example. If anybody saw Michael Smitasen's talk in the R&E section yesterday afternoon, that goes into some detail on this. I encourage you to look at those slides if you weren't there. Underpowered firewalls we see as a huge problem. A lot of people say, oh, I bought a 10 gig firewall. It can do 10 gig, right? Well, yeah, but no single flow above a half a gig or something like that. So there's a lot of issues with firewalls dropping packets that we've seen. Of course, dirty fibers are always an issue. Sometimes the hardware counters catch that. Sometimes they don't. Depends on how good your Nagios alerts are on those sorts of things. And then just slow hosts too. How do you know when it's a network problem versus the receive host is slow in dropping packets? So here's just a few examples that we've seen over the last few years. So here's an example of a line card that just slowly started to fail. So I guess this is over the span of about a month. And it just gradually, performance went down and went down and went down and went down and went down. And in this particular case, I believe our Nagios alerts, or actually Spectrum alerts in this case, didn't trigger until down around here, you know, at the time that it was not sensitive enough. And then eventually, roughly the same time, our alerts triggered, and a user complained, and we quickly swapped the hardware and things got better. But having collected this historical data along the way and being able to generate these kind of graphs is really useful for this kind of thing. Another example that we see all the time, and as I mentioned, is underpowered firewalls, where the two lines are throughput in one direction versus the other direction. And one direction, where the firewall is pretty much letting the traffic go by, performance is pretty okay. Periodic dips, probably a little bit of congestion now and then. But the other direction, it's just terrible. So, but then we installed a persona box just on the other side of the firewall to confirm where's the problem. And you know, right before the firewall, the performance is fine in both directions. So it was definitely the firewall problem. And as I mentioned, host tuning is still an issue, and it's something to be aware of. And it's, you know, a lot of times you start spending a lot of time thinking it's a network problem when it's actually a host problem. And here's an example where we tried to do some tuning by changing the MTU size to jumbo frames. That about doubled the performance, it looks like, but still not great. And then look closer at the TCP tuning settings, and it's like, oh, okay, now we get decent performance. So, you know, the default TCP buffers are still not good for paths of longer than 10 or 20 milliseconds. So you do have to pay attention to host issues as well. This is a slide from Michael Smitason's presentation yesterday that I referred to, just to show that switch buffer size makes a big difference. This is interesting. So the Brocade MLXE, by default out of the box, sets the buffers to only 1 megabyte, which is great if you have lots of YouTube flows and lots of standard, you know, kind of small consumer flows going through it. That's a reasonable default for standard commercial traffic. It's a terrible default for big science traffic. So by changing the Brocade from a 1 megabyte buffer to a 64 megabyte buffer, you can see performance more than doubled. And just here's some other. So we sort of find that there's a sweet spot for high-speed 10 gig flows. Somewhere between 32 and 64 megabytes is the amount of buffer your device needs. And again, like I mentioned, there's a lot more detail in Michael's talk from yesterday. Okay, so that's sort of all background. So exactly what is Personar? So Personar is a tool to help set network performance expectations, to help find these soft failures, to help fix these problems in a multi-domain environment. We like to say you can't fix what you can't find, and you can't find what you can't see, and Personar helps you see. So a bit of history. Personar evolved out of an Internet 2 initiative called the End-to-End Performance Initiative back in the year 2000, so 15 years ago now. So what's changed in the last 15 years? Well, TCP is a lot less fragile. Back then it was only TCP Reno. Cubic is now the default congestion control algorithm in pretty much every Linux distribution. Auto-tuning is on now. It wasn't back then. And TCP buffers are a lot larger. Back then they were set to 64K. They're up to 4 megs. We always set things up to about 32 megs now. There's some good parallel file transfer tools out there these days. The one that we use a lot in our world is called Globus Online. There's also some good UDP-based tools out there like Aspera that get around all these TCP problems if you can afford them. They work great. Just recently, there's been a lot of work in the newest Linux kernel, a lot of it being done by some Google folks. We heard a little bit yesterday about the fair queuing option, and there's a bunch of other stuff going on. And I've done a little bit of testing, but I've heard from other people that, you know, if you use the brand new latest 4.0.4 kernel, a lot of these problems go away with TCP. A lot of the TCP is much more robust in the face of loss. But traditionally, it takes 2, 3, 4, 5 years for things to trickle from the kernel.org kernel into a Red Hat release. So we have a ways to go. But yeah, there's still lots of problems. What's called the wizard gap, the difference between what an average user can get and an expert network sysadmin can get, is still huge. Jumbo frame use is still small, although we are seeing that processors are now enough faster that matters less. Under-buffered switches are still really common. I showed in the last switch you need at least 32 megabytes of buffer to get good performance, and the standard cheap Dell top-of-rack switch has 9 megs per buffer, so it's off by a factor of 3 or 4. Underpowered firewalls are a really problem, and problems often go undetected for months. So the Personar collaboration has evolved over the years. Various organizations have sort of come and gone from it, but we're at its strongest point ever now, and the greatest number of FTEs working on it in the collaboration's history. Right now, the collaboration's led by ESnet, Internet 2, Indiana University, and GEANT, which is the R&E network in Europe. And each of these organizations has committed to at least 1.5 FTEs of effort into the project, at least 1 FTE of developer and at least half FTE for people to go out and do things like I'm doing, giving talks and tutorials. And then we have a lot of help from other people who submit patches, who submit code, et cetera, mostly within the R&E community, but it'd be great if we could get more of the folks in this room to help contribute to the open source effort as well. Our roadmap is influenced by a combination of factors, probably similar to any large open source project. We take requests on the project issue tracker on GitHub. We send out annual user surveys to everybody on our user list, and I think there's 500 or 600 people on the user list now. It's pretty large. I don't know, maybe it's only closer to 300, but there's a lot of people on that list. And then we have regular meetings and conferences and things like this where we collect feedback. And then based on that, every 6 to 12 months, we all meet face-to-face and sort of decide what we're going to put in the next release. So a lot of us in the Personar team kind of interchange the terms Personar and Personar Toolkit. It can be a little confusing, but the Personar Toolkit is a particular bundling of a set of tools. Traditionally, it's all been based on RPMs and bundled into a net install where you can just download an ISO, put it on your USB drive, put it in your computer, and then it goes off and downloads all of CentOS and all of Personar. And then the next release, which will be out the end of the summer, we're also supporting Debian. In general, we recommend Personar run on a dedicated host, and although you can install all these RPMs on other hosts, it's just that if you're running other stuff on your server, that other stuff will perturb your results, and you're not positive if those dips in your graph are caused by other services on your host or whether it's caused by something in the network. But it's really quite easy to install, and typically you can get an entire node all set up, installed, configured in under 30 minutes. So the toolkit includes the following components. There's something called BWCTL, which is short for bandwidth control, that runs periodic testing. The name is a little bit of a misnomer now because it started out just running tools like iPerf and iPerf3, which were bandwidth tools, but now BWCTL also runs ping and traceroute and a number of other tools. So it's not really about bandwidth anymore, but I don't think we're going to change the name. That'll confuse everybody. There's a tool called OAMP, which is actually an RFC 4856, for measuring one-way latency and loss, and it actually measures jitter and reordering as well. Our monitoring archive is called ESmond. I think that's short for ESnet monitoring daemon. It came out of a different ESnet project, but we adapted it for Personar. It's basically a time series database that's optimized for this sort of data and has a REST API. There's a lookup service that all the Personar nodes in the world register to, so you can find other nodes to run tests against. There's a couple historical tools like NDT, which is short for Network Diagnostic Tool. That's the tool that you hit if you go to Measurement Lab, if you've ever done a test to mlab.org. It's the NDT tool, but that's bundled as part of the Personar toolkit. There's a bunch of GUIs to make it possible to set up all this stuff, configure it, configure NTP and things like that, and set up regular tests and then view the results. So currently we have over 1,400 Personar nodes worldwide. You can see that we have pretty good international coverage, although these ones in Mongolia are actually people who got their lat longs wrong. They missed a minus sign. But in general, most of the rest of these are actually accurate. And 1,400 is a big enough number now that it's really useful. Now, these are the ones that choose to register themselves in the global public lookup service. We estimate there's probably at least that many more that aren't, that people don't want the world to know about them. And just because they're in the global lookup service doesn't mean you can necessarily run tests to them. Different people have different ACLs in front of their hosts. But you can at least get the email address of the sysadmin of that host and say, hey, please, could you change your ACL so I can run some tests to you? And in general, people are pretty willing to do that. This one just sort of shows our growth curve for the last 3 years. It's pretty steady, solid growth. A couple dips when various security incidents occurred. You know, if people weren't really using the box anyway, sometimes it's easier to unplug it than it is to patch it. But you know, the growth curve is pretty steady. So at current growth rates, you know, we'll be up to 5,000 or 10,000, not that far away. Yeah, so just a word on active versus passive monitoring. And I'm just curious, like, how many people in the room do some sort of active, not including persona users, how many people do active monitoring on their networks? Okay, so a fair number, yeah. So it seems like 10 years ago, nobody wanted to do active monitoring, and everybody was afraid of active monitoring. But I think people are more and more understanding the value of it. So I think we all know that passive monitoring systems just have various limitations, and there's only things you can get if you're doing some sort of active monitoring. So one of the tools that's part of the Persona suite is, it's called Mad Dash. It's a dashboard tool, so you can quickly set up, you can quickly see for the endpoints you care about, what's the health of everything. This particular dashboard is the ESnet internal dashboard. We have a Persona node co-located with every single router in our network. So that's how many routers we have in our network. And this is the throughput testing dashboard. And I think the reason that some of them are yellow is that they were old hosts. I believe if you go to the dashboard today, and that's the URL. This is all public. Anybody in the world can see this stuff. You can poke around in there. So it's a really nice way to see just the general health of your network. You know, and you may or may not want to make something like this available to your customers. That's an individual choice, but just internally, it's a very useful tool. And then also we have Nagios plugins that leverage the dashboard setup, so you can also generate Nagios alerts on this stuff if you want. Although, as was mentioned again in the Facebook talk yesterday, getting the alert threshold right can be tricky. So as I mentioned, we definitely recommend Persona be run on dedicated hardware, but these days that hardware is pretty cheap. You know, recently you can get a 1U host capable of driving TCP at 9.9 gigs for about $500, not including the cost of the NIC, of course. I mean, the NIC's going to be another, you know, $1,000 for the NIC plus $200 for the optics. But it's a pretty cheap host. And a 1 gig Persona node is still quite useful, even if your network is all 10 gig or above. That's actually quite okay. And because of that, actually, we've been working on trying to get the cost of a 1 gig node down under $100. And we've done some testing on both some ARM devices and some Celeron devices. Turns out the ARM processors, at least we haven't found one that'll push TCP more than about 400 megabits per second. But a Celeron processor, you can get 900 megabits per second, maybe 990, I don't know. So we're currently experimenting with this device from Liva? I don't know how you say it. And plan to officially support some of this lower cost hardware in the next release. The Persona tools work on VMs. They have value in VMs. I won't say they have no value. It's just it's much harder to interpret the results. I mean, unless you're really careful about how you set up your VM and dedicate NIC bandwidth, you know, physical NIC bandwidth to your VM, you just never know what you're competing against. So, I mean, we tell people it's better than nothing, but especially if you can put it on real hardware for $100, that's much better. I just want to mention that the community is actually quite active. The email list is quite active. We probably get, on average, 3 to 5 emails a day to the user list, about half of which get answered by other members of the user community, and about half of which get answered by people who are part of the Persona consortium. People discuss all sorts of things, everything from what Persona hardware should I buy to I'm experiencing this strange problem. Anybody have ideas how to debug it, or where can I run tests to, things like that. So it's we've been quite happy with the activity of the community, and those are the URLs for subscribing. Okay, so next I'm going to go into some specific use cases and success stories, but any quick questions on what I've done so far? Okay, well, I'm going to go through several more examples of where we found Persona really useful for debugging things. Yeah, okay, so the first one is the one I already covered. This is the gradually failing optics. I don't think I have anything else to say about that. Here's an example from a few years ago this was showing the packet loss data. And you can see there was tons and tons of packet loss. And then somebody finally figured out they needed to install an attenuator. They must have been overdriving something somewhere. And the packet loss got much, much better. It didn't go away completely, but it got much better. And so these sort of historical graphs are really easy to see this sort of thing. Now, I would hope that this one could have been detectable through the right SNMP monitoring that apparently they weren't doing. I'm not sure. Here's some more examples, some more details on that firewall example. So this was at Brown University, and I think this is a fairly typical network configuration that I believe this was their. Let's see. Yeah, this was a particular physics host deep inside the campus. It had a couple switches on the way out to the gateway. Yeah, and that's that's probably their site border router, and then there was a firewall, and then some more switches, and they had another test host, and so the basic idea that you have to go through this firewall to get anywhere from the outside to the inside. And I showed this graph already. One direction was just fine, the other direction was terrible. I mean, you can see this is less than 100 megabits on a 10, and that entire network in that last graph was all 10 gigabit. And they were able to get less than 100 megabits because of this firewall. So first of all, prove that everything's fine up until just before the firewall, and it is. And then actually run some detailed tools that give some TCP retransmit numbers. NUT-TCP is a nice tool that actually shows you the TCP retransmits. And not without the firewall, as you can see, it's totally, totally clean. You get 940 megabits per second on a 1 gig host. That looks pretty darn good. Going through the firewall, wait a second. I lost part of that slide somehow. But anyway, you still get the idea. Constant retransmits and terrible performance. And again, from that TCP graph I showed earlier, you can see that just retransmitting 7 packets in that 1 second interval took performance from 940 megabits down to 44 megabits. On that particular path. It must have been a fairly lengthy path. So it's amazing how much time we spend with firewall issues. There's a lot of underpowered firewall issues out there, a lot of old firewall issues out there, and a lot of people who don't really read the fine print on their firewall. That's their 10 gig firewall, because a 10 gig firewall does not mean it can do 10 gig flows. It means it can do an aggregate of 1,000 100 meg flows. It does not mean you can do 10 gig flows in general. But I mean, there are firewalls that can, but they're clearly more expensive. Here's just another example of host tuning, a really long path. Again, these days Linux defaults to 16 megs of TCP buffer. By increasing that 16 to 64, it automatically went, well, more than twice as fast. So just a simple host tuning makes a big difference. Persona helps point these issues out. Here's just an example plot of a fiber cut. I mean, of course, perf sonar, like I said, there's lots of other tools that can find fiber cuts, but it is kind of interesting to see the graph and to give you the history that shows there's a big loss spike, the latency changes, why it routes on it, sends the traffic on a different path for a little while, something gets fixed, and then they take it back to the original path. So we see lots of things like this in our perf sonar data, which of course makes it a little bit challenging to generate Nagios alerts on this stuff, because you're going to find out about that some other way, and you don't want to necessarily generate Nagios alerts on all loss events like that, because a lot of them are already going to be dealt with, and it might even be a planned maintenance event. So here's a more complicated example. These are the newer style perf sonar plots. And these take a little while to kind of wrap your head around. This graph, this axis on this side is throughput, megabits per second, which maybe you can read. I can't at this resolution. And on this side, it's latency and loss. So we have all three plotted on the same thing. And you can see the color coding down here. And you might be able to see this better if you download the slides. But here we can see there's a lot of loss going on. Performance goes down quite a bit with all these loss spikes. Somebody makes a change where the network takes a different path. Latency goes up, but performance goes up and the loss goes away. And then at some point, they decide to change it back, and at that point, it's fixed. There's some random loss event down here. Don't know what that's all about. So there's a lot of information presented in these graphs. We're working on better ways to present this because they are a little bit confusing. And they take a little bit of getting used to, but there's a lot of information. Here's another example of where MTU can make a big difference, changing the MTU from 1,500 bytes to 9K. Performance got much more consistent. I mean, it was periodically fine, but there was lots of drops, I guess, due to other traffic, but then by making it jumbo frames, things cleaned up quite a bit. And this is also another common profile we see. The more of these graphs you look at, you start to recognize patterns where performance is in one direction is consistently good. Performance in the other direction is all over the map. This is typically a 10 gig host sending to a 1 gig host. That 1 gig to 10 gig, everything is fine. 10 gig to OneDrive, you're overdriving the receive host periodically, and TCP just becomes a lot more unstable. It does seem like if this switch right before that 1 gig host has deep buffers, this isn't as bad of an issue, and you can paste traffic out of the 10 gig host as well to get rid of this. But this is a sort of common signature that you can see that then once you've identified it, you can try to resolve it. So this is a recent example that I think is pretty interesting. It's just from a couple weeks ago, and I think it's a good perf sonar success story. And this was on the Internet 2 network in Washington, D.C. And sometime, and of course this happens on a Saturday morning, right? These things always happen on a Saturday morning. Performance just drops tremendously, and packet loss goes up tremendously. And the SNMP counters were indicating nothing. This was one of those cases where the hardware was failing, but the error counters were not increasing whatsoever. And so perf sonar immediately found a problem, and immediately the Nagios alert went off and generated a trouble ticket in the Internet 2 NOC, or I guess actually the Indiana NOC, because they run it for Internet 2. And but it took a while to track this one down, because it turned out it was a line card that went between a Brocade and a Juniper, like in the same rack. And just because you know there's a problem, you don't know necessarily what hop it's on when the error counters are not telling you anything. So I don't know how they finally tracked it down, actually, but I do know that by Monday morning they had figured it out, swapped the line card, and everything got better again. But this is a case that only perf sonar, only the active monitoring detected this. Passive monitoring completely did not detect this. Mm-hmm. Well, this is the per sonar tests, which are, in this case, just attempting to do, these look like just 1 gig hosts. So it's just doing four times a day, 20 seconds, try to fill a 1 gig pipe. So if that's, so I guess that's large. Depends on your definition of large. Yeah. So sort of the summary of that set of slides is that this type of active monitoring is really good for finding certain types of problems that passive monitoring doesn't necessarily detect. And the problems might be in the end host too, not just the networks. I don't know how many times I've heard people pointing at each other. No, it's a network problem. No, it's a host problem. No, it's a network problem. This stuff helps a lot with that. And just be able to see the long-term trends is extremely useful. You know, to show, you know, just to be able to show somebody a plot and say, hey, look what happened yesterday. My performance dropped by a factor of 5. Did you make any changes? I mean, we've done that a lot. We'll take a screen snapshot and then send it to the next network down the path and say, hey, did you do something? Look what happened here. You know, and then also if people do upgrades, they spend money, they want to see an impact. This sort of testing is good for that as well. Okay, so next I'm going to go into the next section on where you should think about deploying per sonar nodes and what sorts of tests you might want to set up. Okay, so I think I've said a lot of this already. I mean, we don't want to wait for users to report problems. We want to be proactive about this. We want to be running active tests. We want to notice them and fix them before users report them. Again, the Facebook guy really set me up well yesterday because he mentioned that as well. And things just break. You know, hardware fails, somebody messes around with a patch panel and kinks a fiber. That's annoyingly often that happens. And problems that get fixed have a way of coming back too. You know, you don't, you know, if a user does report a problem and you go in and fix it, you want to start monitoring to make sure that problem doesn't creep back in. In particular, we see this all the time in the host world because somebody will go in and tune their host, and then 6 months later they'll upgrade their host and their tuning settings will all get clobbered. So just having this regular background monitoring makes a big difference. And again, the dashboards are a really nice, easy way to show yourself, your users, your bosses, whatever, that everything's running clean. Despite the Dilbertness of the dashboard, I'll let you guys read that. They can be rather Dilbert-esque. Yeah. But I think there's at least 10, maybe 15 public dashboards out there that people are running. People set up monitoring between their endpoints of interest. If you just Google for PerfSonar and Mad Dash is the name of the dashboard software. You'll also find where to download Mad Dash, of course, but you'll find a number of public PerfSonar dashboards, some of which look very green and some of which look very not green. So in general, we recommend PerfSonar hosts be deployed near key resources such as data servers. And you know, in general, you're trying to confirm that you can get data in and out of your data server as quickly as possible. So putting a PerfSonar host on the same subnet is very useful. But the more PerfSonar hosts you have along your path, the more you can isolate which segment has the problem. Like I said, we actually have a PerfSonar node next to every one of our layer 3 routers. So we know exactly what layer 3 segment has the problem. Now, that layer 3 segment, of course, might be composed of multiple layer 1, layer 2 segments, which it's still harder, but it's being able to isolate as much as we are is still very, very helpful. And more often, we find that that's the case, that there are enough PerfSonar nodes out there to be able to do the right sort of debugging. So here's an example persona host placement diagram. I think even though this is an R&E diagram, I think the concepts are general. So you have your wide area network. You have the first router that you hit going to the wide area, and you put a persona node there. In this case, this is the backbone provider's router. This is the site router. If there's two, you can put a persona node in both of them just to make sure it's clean to your administrative boundary. There's a firewall. You might want to put one just inside the firewall. And if you have a big compute cluster that uses a lot of resources, you might want to put one there, but mostly it's by the storage server. You want to put one there. So you'd want to be able to verify I can get from my storage server network to in and out of the firewall. So that's like the first test you'd set up. And then you want to verify you get from just outside your firewall to your customer at the other end of the WAN, so you run a test to them. And then you might also run a test between here and your customer as well. And as these things are now in the range of $100, there's no reason to not do that. Mm-hmm. Mm-hmm. Yeah, I do have a slide. Sorry, yes. He says, if you're running all these active tests, what kind of impact does that have on your network? And that's an important point, and I have a slide on that later. But just briefly, number one, TCP is designed to be fair and back off, so you shouldn't, everybody will be competing with everybody. Two, yeah, you got to be a little bit careful not to do too much testing, absolutely. The persona Toolkit actually has a little indicator in the GUI that says your test will be using N% of your network, and in general, I don't think anybody would want to let it go above 5% or something like that. And then the other thing we do on ESnet is we actually tag everything scavenger service, and we configure our routers to drop scavenger tagged stuff first. So that's the other way to just make sure that this test traffic is the stuff that gets dropped first. That doesn't typically work multi-domain, though, of course, right? And typically, people strip those bits as they transfers from one domain to the other. So in general, with the regular persona tests, we're checking for 3 different things. We are checking for TCP throughput, and that is the one that puts the most bits on the wire. Some people don't do that. Some people don't run those tests for that reason. We check for packet loss and delay, and I'm going to talk a little bit more about the OAMP tool that does that. And then we do trace routes or trace paths. And the next version is also going to support Paris trace route. That seems to have some nice features that a lot of people are using these days. So then all these regular tests, and typically the TCP tests run 4 or 6 times a day. That's how most people set it up, 20-second test 4 or 6 times a day. So it's not very much, except that's per endpoint. So if you're testing to a lot of endpoints, that can add up. The packet loss test just runs continuously, 24/7, but that's a very small amount of traffic. And the trace routes, I think the trace routes run every 30 minutes, actually. I believe that's the default, but you can configure it to do whatever. But again, all this data is then collected in an archive. There's tools to graph it. There's tools to integrate it with Nagios. So in general, people set up their nodes in one of 3 ways. Either it's what we call a beacon node, where you just bring up a node and you let people test to you, or you let some subset of people test to you. You don't actively run any regular tests yourself. You're just there so other people can test to you. It's mostly, I guess, useful for those other people than it is for yourself. But it can be useful for troubleshooting exercises. The island model is where you pick some host to test to. you're just sort of configuring one node that you're testing out to a bunch of different places. I have another slide that goes into more detail on that. And then the mesh model is its full coordination between a whole lot of nodes, which is what's used in these dashboard examples. Yeah, so a little bit more detail on each of these, I guess. So yeah, the beacon node, I think, is more common for a backbone provider, where you're putting some nodes out there so that people can test to you, so they can verify that they can get from their campus to the wide area cleanly. We sometimes set these things up as layer 2 devices as well. They don't have to be layer 3. You can put VLANs on them and plumb the VLAN all the way through to this remote testing node. Yeah, typically people enable all the different services. Some nodes might just have bandwidth tests enabled or latency tests enabled, but in the beacon mode, you typically do both. Yeah, the island node allows the site to test against any number of sites around the world. So you go in through the Toolkit interface and say, I want to test to this set of hosts. These are the places I care about. And then you can go in through the testbed user interface and see the results of those tests. This is sort of the mode that a lot of times people, when they're starting to use PerfSonar, they're just sort of kicking the tires. This is what they do. They bring up one node, and they run a few tests, and they find out how useful it is. And then after a few months of using PerfSonar to find some problems, they usually get a little bit more excited about it, and then they say, I want to set up a whole mesh. So I want to set up a bunch of nodes inside my campus, and I want to run regular tests between them. So PerfSonar supports the notion of a centralized config file that all your various hosts will then download, and it tells them where to run their tests to, where to send their results. You can have a central archive, et cetera. So they're all valid use cases. So in general, we recommend you pick a few test points that are not too far away. You definitely run to your test to your most important remote end sites. If it's a big company with distributed campuses all over the world, you'd run tests between all the campuses. Again, you run the bandwidth test. We typically say to run 4 to 6 times a day, 10 to 20-second tests, depending on how far away it is. And then you also configure the OAMP tests for anybody you care about monitoring packet loss on. And then hopefully you're, of course, monitoring everything with SNMP as well and have a way of correlating back so that when you see loss with OAMP, you're able to go to your SNMP and say, oh, that's congestive loss, that's not congestive loss. So we have something called the service directory that lets you find hosts all over the world to test to. You can search for various filters. If I want to find a host in New York to test to, you can just type in New York and it'll bring up all the New York hosts. Again, this is public, open to the world. You can all log into it right now and try it, although if you all do it at once, I'm not exactly sure what will happen. If you type in .com, you'll see there's currently about, 40 or so nodes in the commercial internet that actually are registered in the lookup service. I haven't tried to run tests to them. I kind of doubt if you can, but even most of them are in the R&E world. Most of them have .edu suffixes, or they're mostly science, but we are definitely seeing more and more uptick by the commercial world. And we're aware of several kind of small regional commercial networks that run it internally, but that don't publish any of it. Okay, so this kind of, whoa, what was that? Somebody's trying to talk to me. I should have turned off the network, I guess. Okay, so yeah, a lot of people are concerned about, okay, well, isn't this going to perturb my users' traffic? So you have to be a little bit careful. do most of these 1,400 hosts accept tests from anyone in the world? You guys see a different screen than I do. Oh, that's really annoying. Okay, we will turn that off. Of course. Okay. So so some of those hosts are actually wide open. Anybody can test to them. You can test to them from your home network. You can test to them from anywhere. And in general, this project has been under the radar enough that I don't think anybody's taken advantage of that. I haven't heard of anybody DDoSing a Perfsonar host. I haven't heard of a Perfsonar host being used to DDoS the world, but it could happen. The way we run our hosts in ESnet is that they're wide open to the R&E community. So we use our routing tables to build a set of ACLs that anyone in the R&E world can test to it, but I can't test to it from my home DSL line. You won't be able to test to it from your corporate network, unless you ask us, and then we might open it up. We can change our ACLs. And a lot of people run it fairly tight ACLs. They only allow testing to the people they really care about, and there's just a short list of people who can run tests to it. Now, we have heard of cases where people set up too big of a test mesh and it's impacted their production traffic, particularly if you have a bunch of 10 gig Perfsonar hosts and you have a 1 gig bottleneck somewhere. It's pretty easy to impact things. So you got to be a little bit careful. You got to think about it. And maybe you just want to run the latency and loss test with OM. Maybe you don't want to run the TCP test, although we certainly see a lot of value with that. Now, some people use ACLs in the router in front of their Perfsonar node to control traffic. Some people use host-based ACLs to control traffic. And then the BWCTL tool actually has its own way of controlling traffic. It has a file called the pwctl.limits file, where you can put in a list of subnets that you trust and what they can do. So for example, ESnet lets TCP tests for the entire R&E routing space, but UDP tests, it's just us. It's just our own subnets can run UDP tests, because that's potentially more disruptive. So there's a lot of flexibility in the tools and controlling who can run what test to who. And then future versions of WCTL coming out late this summer will have even more options. We've had requests to say, I only want to allow TCP testing between the hours of midnight and 6 a.m., for example. Or, these people I'm willing to let run 6 times a day, but these people I only want to let run 2 times a day. So there's going to be a lot more controls like that in the next version. Okay, next I'm going to really kind of dig into the details of some of these tools. Any quick questions before I go there?
Charlie from Yelp. I'm wondering, have you heard of anyone baking Amazon images and testing between AZs?
Yes, actually, we have. I'm trying to remember the details, though. Yes, we. I can get more details, but it's been done. Yeah. It does have some of the VM issues I talked about, and I believe, there's different flavors of Amazon hosts, and depends on how much you pay, you'll get much better performance. That we've sort of, I think we've verified you get what you pay for, or you don't get what you don't get paid for. Okay, so all the graphs that I showed were generated using data that came out of one of the following tools. So the toolkit includes these Perfsonar-specific tools, BWCTL and OAMP, and then standard Unix tools of ping, traceroute, tracepath, and soon Paris traceroute. and then standard Unix add-on tools of iPerf, iPerf3, and NUTTCP. So that's sort of the core of Personar. You know, people are always coming up with new network tools, and we'll always consider adding them to the toolkit. So sort of the workhorse throughput tool, though, we're using is iPerf3. I'm sure everybody in the room is familiar with iPerf, the traditional iPerf. How many people know about iPerf3? Just curious. Okay, pretty good, pretty good. The iPerf3 maintainer is right over here. And if you have complaints or requests, or better yet, patches, talk to him. So iPerf3 is a complete new implementation of iPerf from scratch. It's very similar. It'll look familiar to standard users of iPerf. It's just the old iPerf code had gotten really, really hard to maintain, really hard to extend, and it was just decided it was easier to start from scratch. The new features in iPerf3 that aren't in iPerf, and to be honest, a lot of them were just borrowed from NUTTCP, which has pretty much all the right features, maybe except the JSON output. But that code was also unmaintainable. So it's the combination of the features from NUTTCP with something we can actually maintain. But you know, it reports TCP retransmits. It reports TCP congestion windows, so you know if your congestion window limited. It supports zero copy option, et cetera. And you can also, there's a quote omit flag, so you can ignore the first n seconds of the result. So that way you can skip the TCP ramp up period and just measure the end of the transfer. So just a simple example. It looks a little bit like NUTCP. Here's a fairly lossy link. I think this might have been using NetM to do like 1% packet loss. You'll get tons of retransmits, and you'll see the congestion window never opens up. And you know, if you see something like that, you know your network's pretty broken or pretty congested. So BWCTL is the tool I've been talking about. It's the wrapper for all these other tools, and basically it's a scheduler, and it makes sure that only one tool runs at a time, or at least one tool that might perturb other tools runs at a time. So that's the big advantage. You don't know if multiple people are running tests to your host at the same time. You don't want all those tests to go on in parallel because that'll just completely confuse the results. So BWCTL guarantees one tool at a time, and it guarantees who can run it and for how long, things like that. Just some general notes. The command line options are -C and -S, which you might think stands for client and server, and maybe does stand for client and server, but that terminology is actually really, really confusing in a third-party mode, because you can tell BWCTL to run between two tests. So the way we like to tell people to remember it is C is the catcher and S is the sender, because client and server is just really confusing. It defaults to v6 if it's available. That sometimes confuses people. So use -4 if you really want -4. And it lets you run all the following tools from anywhere. Typically, I will sit on my laptop. I don't have to log into one of the end hosts. That from your laptop, you can launch a tool between any two Personar nodes. So you can run iPerf3, iPerf, NUTTCP, ping, OW ping, which is the OAMP tool, traceroute, tracepath, all from your laptop between any two Personar nodes in the world if you have the right permissions. So just some examples. Launching iPerf between these two hosts, launching ping between these two hosts. If you're not pinging a Personar node, if you're not pinging a host running BWCTL, you can use the -E flag and ping just anybody. BW traceroute will launch a trace path with the tool option between those hosts, etc. So it's pretty neat to be able to do all this from your laptop, and not have to have logins on all these things. So, keep in mind that your throughput tests are very much dependent on your TCP buffer size. And as I've mentioned a couple times, default buffers are still not big enough. I mean, even if you're just trying to do a 1 gig flow, not even a 10 gig flow, across country, you need a buffer of about 12 megs, and the defaults are only 4 megs. So there's lots of information on the fasterdata.es website that I've been maintaining for about 10 years. And you can see how to make sure your hosts are tuned properly. Let's see. I got to speed up just a little bit. Yeah, a couple things that's important to keep in mind. Sometimes people get confused in what their expectations are in their network throughput. I mean, you're not going to get your capacity necessarily. You're competing with other traffic. It's not telling you what your utilization is. It's not telling you what your capacity is. It's telling you what a user might expect at any given time. And a lot of tools, a lot of users are using parallel transfer tools. A lot of users are doing disk to disk, not memory to memory. So you have to keep all this in mind. This, by default, is doing one stream, memory to memory, which may or may not have that much in common with what your users are actually doing. BWCTL, as I mentioned, can manage iPerf, iPerf3, and NUTTCP test tools. I don't want to spend too much more time on this. I'll go through some of these examples. So this is what it looks like from the command line. Hopefully you can read that. If not, look at your slides. So it's kind of the canonical examples. You run BWCTL, tell it to run iPerf, tell it to format the output in megabits per second, run for 10 seconds, give you an interval report every 2 seconds. And in this case, it's just giving it one host name, so it's from the host I'm logged into to that guy. And standard iPerf output that you're all used to. And yeah, that's the value that ends up in all those graphs. iPerf3, which is now the default on the toolkit, gives you some more useful stuff. You don't have to do the -FM option anymore. That's the default. But it tells you the retransmits, which is super useful. And the final throughput number. And again, that's what's graphed. And all this gets stored in the database, including the 1 second interval reports, not just the final numbers, et cetera. And one little batch of retransmits coming out of slow start seems kind of common. If your retransmits are only in your first interval, you usually ignore it. It's when you get periodic retransmits every few seconds that you start looking for soft failures or congestion. NUTTCP actually has a lot more information by default. It's just harder to read sometimes. I mean, it tells you exactly what send windows are that it negotiated. It tells you all about, it tells you the throughput again, tells you the retransmits. It tells you the CPU used by both the receiver and the sender. That looks like a, and iPerf3 tells you the CPU info too in verbose mode, but I'm not positive that the BWCTL captures that or not. I think it might, but anyway, that's more options. Here's an example of NUTTCP on a lossy link. It's kind of what you'd expect. So throughput expectations, a lot of times people think, oh, well, I have an end-to-end 10 gig network. I should be getting 9.9 gigs, right? Well, it really depends. You have to, there's a lot of factors that go into that. One is just the round trip time and how long will it take TCP to ramp up. One is, have you done all the right TCP tuning settings? Two is, how fast are your hosts actually? And particularly if your sender's a lot faster than your receiver, you might overwhelm the receive host. And the receive host might drop packets. So there's kind of a lot that could impact that. But as a general rule of thumb, we tell people that if you're not getting at least 3 gigs on your 10 gig network, dig into it and figure out why. That these days you should be able to get 3 gigs if you've set stuff up right. Okay, so the OAMP tool, which I've mentioned a lot, stands for One-Way Active Measurement Protocol. And so it's like ping on steroids, I guess, that captures all this information: loss, duplication, out-of-order packets, latency both directions, number of layer 3 hops, etc. Now, OAMP doesn't work at all unless your hosts are synced with NTP, and it checks. It figures out if you're in sync. So you have to make sure that your clocks are in sync. Otherwise, it doesn't work. Like I said, I got to speed up just a little bit so we have time for questions at the end. So here's an example for OAMP output, where it says, by default, it sends 100 packets, 10 packets a second. They're very small packets, and monitors how many were lost, whether there are any duplicates, what the delay and jitter is. In this case, jitter was, I guess, it rounds it to the nearest millisecond, so it's calling that 0 jitter. It says there were 7 hops and no reordering, and then it tests the other direction. So by default, it runs, it's a bidirectional test. And again, this is the data that ends up in those plots. And there's a mode where it just runs this continuously. You can either run it periodically, or it just runs in continuous mode. So here's an example where lost 12% of the packets. There's an example with some reordering. It tells you how many packets were reordered by 1 and how many were reordered by 2. You'll get that on lags fairly often. Reordering may or may not really be a problem. So this is just an example of of a very lossy path in the OAMP plot. So it's plotting the latency in both directions. So that looks a lot like an asymmetric path, which again may or may not be a problem, which at some point they fixed and made it basically a symmetric path, which didn't really seem to solve the packet loss problem. So clearly the packet loss was somewhere else. But that's the kind of plots you can get from the latency data. So just an example of a third-party trace route. Again, this is so useful. I mean, how many people would like to be able to run from their laptop a trace route from anywhere to anywhere? This is how you do it. As long as the BWCTL is installed, you just have your sender and your catcher, and you can run a trace route from anywhere to anywhere. It's really, really useful. Or the trace path example, these days we're seeing more and more people deploying jumbo frames, but then maybe not quite getting it right. So I've started using trace path by default just so I get the path MTUs. There's an example where it's jumbo clean. Here's an example where at that hop it goes from a jumbo frame to a non-jumbo frame. I mean, it does it well, but you can see exactly what segments are jumbo clean and what segments aren't. Very, very useful. You can just run pings from anywhere to anywhere, also very useful. And run OAMP from anywhere to anywhere. So just a couple testing pitfalls to mention. One, don't just run one test and jump to conclusions. You should run the same test 3 or 4 times. Make sure there's a trend. Your network's constantly changing out from under you, so one test may or may not be meaningful. Standard line, a poor carpenter blames his tools, I think fits this world as well. A lot of times we get to the point in a troubleshooting exercise, you go, man, if they only had a perf sonar node there. And sometimes you can convince them to do that. Or, if you have these cheap little $100 nodes, you mail them one and say, please plug this in there. That's more and more common. But now that we have 1,400 nodes out there, it's more and more common. You don't need to do that too, at least in our world. So the slide set has lots of URLs. You can download the slides to get that. And I just end with a couple movies of screen captures, but if you were poking around while we went, maybe you saw some of this. This is just what the The dashboard looks like you can hover above a box and get the results for that particular box specifically. You can set your own custom thresholds. These are all configurable, that what you want to be is green and yellow and red. And then you can actually click on any box and it'll bring up the detailed plots. And, yeah, I guess this is just going to bring up a plot. I'll go to the next slide. And this one just sort of shows how you can interact with these plots. You hover over the one down here, and it highlights the specific line. You know, these things get kind of messy, so sometimes you want to look at it just one at a time. You can also click the check boxes to turn things on and off. You can quickly zoom in and out between different resolutions. By default, it's a week, but you can go back and see what it was like for the whole month. And you can see this is pretty fast. The database on the back end stores RRD-like summaries of the data. It stores all the raw data. It doesn't throw it away the way RRD does, but it stores summaries that lets you go between 1 day, 3 days, 1 week, 1 month very quickly. But again, a lot of this stuff, you can just go to these public dashboards and play around with it, so you can get your own experience with it. I think I'm going to end it there, and I wanted to make sure to save the last 10 minutes for questions. So.
Going back to your original statement about the large-scale networks, where let's say you were troubleshooting an extremely large pipe you're built from Bay to Chicago. How do you guys handle, let's say, single port issues? Like, let's say 110 gig out of your 100 was black holing 4 gigs of traffic, right? So how do you work around vendor hashing, for example, across the lags?
I don't know. We haven't experienced that issue. I guess I don't know.
Because you mentioned one of your use cases was the Brocade to Cisco problems, right?
Right.
Yeah.
Brocade to Juniper, actually.
Yeah. So
Yeah.
I was wondering if you had run into that, or how you were figuring out. So the biggest problem is if you wanted to change your source IP address
Right.
by a couple of bits left or right,
see,
you should
yeah.
be able to bend it across different links in the lag, right?
Yeah. No. In general, we use very few lags.
Right. Interesting.
So I mean, we stay away from lags partly for that reason. I think it's just
Okay.
so we don't have to deal with that. Yeah. No. I mean, our backbone network is all 100 gig native, and
Interesting.
and the tails are just 10 gig. Yeah.
Okay.
Some of our customers use lags.
Right.
And I know, but yeah, we don't have that problem.
Okay. Cool.
Yeah.
Thanks.
Yeah. Mm-hmm. I think that's the long-term vision. Yeah, the question is, have we thought about higher level analytic tools that actually, I guess, pinpoint the problems and send messages to the... Mm-hmm. Did folks hear that, or should I? Not really. I mean, the short summary is, you know, higher analytics, predict future problems, alert users. I think that's a long-term vision, but I think that's a ways away. And there's still too many hidden hops too that you know, to know really where the problem might be. Yeah, yeah. Mm-hmm. Yep. Yep, yep, yep. Mm-hmm. Mm-hmm. Yeah, I think that's a great idea, and I think we're thinking at least in terms of that way generally, but remember, we're actually only a total of 6 FTEs, 4 developers, and we were only 2 FTEs a couple of years ago, so it's a relatively small project, but yeah, I think that's clearly the vision. Anybody else? Yeah?
Have you approached any of the public bandwidth test providers for maybe putting these on their locations? Ookla allows that to happen already on a limited basis. It seems like a natural step.
Yeah, we haven't talked to them per se. We've talked a little bit to the measurement lab folks. We're kind of targeting different things, and in particular, the problem is that if you're running a test where one endpoint's a browser has an inherent limitation of 500, 600, 700 megabits per second. So even if your laptop had a 10 gig NIC, you know, Ookla, and you're going to a 10 gig host, so yeah. Right. Mm-hmm. Yeah, that's an interesting point. We haven't talked to them directly, and maybe we should. And again, we have talked to MLab, but they're sort of a different use case. They're just trying to understand things like TCP dynamics. And the other thing we'd like to talk to, if there's, you know, the right people in the room, is wouldn't it be great if you could get an embedded BWCTL daemon inside your router, so you don't have to deploy a host at all? I mean, most routers these days have a Linux or FreeBSD engine inside of it. Yeah.
What can you do to visualize
So, yeah, I didn't talk about that. For certain troubleshooting scenarios, so first of all, like regular UDP testing scares the hell out of people, right? Everybody's just doesn't want to, you know, you really want to make sure the hosts are pretty locked down if you're letting people run UDP tests to them, because it won't back off. But there are definitely troubleshooting scenarios that we, I mean, I've seen a lot of cases actually, like of a failing optic, for example, that you only will see it if you drive about 2 gigabits per second of UDP traffic through it, and then you'll see the problem. So there's certain, I'll end up using the NUTTCP tool in UDP mode at the command line for troubleshooting fairly often. But as far as regular testing goes, well, Internet 2 actually runs regular UDP tests on their backbone because they have enough spare capacity. But yeah, I think there's potentially more value there than that we haven't utilized yet. And in fact, there's a NUTTCP tool has a mode that it's a burst mode that's actually useful for detecting whether there's an underbuffered switch in your path. You can send if a burst of 20 packets goes through totally clean, but a burst of 200 packets drops, that's a good indication you have an underbuffered switch in the path. Yeah.
Hi, I'm Flavio. So you started talking about active measurements versus passive measurements. Are you aware of someone that uses like both and correlates to take decision?
Yeah, so interesting point. So the original version of the Percenter toolkit also had SNMP built in. We had embedded cacti into it, hoping that people would turn that on, that would send SNMP data to the host so that you could do those sorts of correlations. And we've done a little bit of that internally. It just turned out that people are sensitive about, I mean, the general mode of perf sonar that, you know, the community we've been pushing it to, it's open, 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 open. And we couldn't convince people to open up their SNMP data. Now, if you're deploying it in a closed, you know, corporate network or something, then you could probably do that. But yes, absolutely. Just, like I said, if you're trying to figure out whether it's congestive loss or non-congestive loss, you need to bring up your OAMP data and your SNMP data at the same time. And to be able to overlay them is exactly what you want to do. It's just, it hasn't been a priority to us because in our community, we haven't been able to get people to publish their SNMP data. Anything else, or are people ready for lunch? I know I'm ready for lunch, yeah.
So is there any way to digest the data out of the system or export it into
Yep.
existing platforms and their code?
I don't know what existing platforms expect other than, I mean, there's tools to pull it out in CSV, yeah. I mean, JSON, it's just a REST query. You can actually use wget or curl with the right magic commands to pull the data out. Yeah, by default it just comes out in JSON, but we have written a little Python wrapper that will also convert it to CSV. So yeah, I would like to hear more about people trying to do that actually. Okay, well I think maybe we wrap it up here and people can feel free to ask me questions the rest of the day.